Renewable energies are the key to climate neutrality, but they have a major weakness. Wind and solar power don't always generate electricity when we need it. Sometimes there's too much energy in the grid, sometimes too little. This is exactly where hydrogen comes into play. Can hydrogen solve the storage problem of renewable energies? Because to create a truly sustainable energy supply, we need solutions that make excess green energy usable, even when the wind isn't blowing and the sun isn't shining. But how can electrolyzers be efficiently integrated into existing energy systems? That's what I'm discussing in this episode with Mariana Sigoli and Philipp Glaser. You already know Philipp from our previous episodes. Mariana completed her master's degree in renewable energies and is one of the key people at Siemens when it comes to smart infrastructure for green hydrogen.
Get ready for Hydrogen, a Siemens podcast with Michael Pretorius and Philipp Glaser.
A question for both of you. Maybe Mariana would like to start. How can we efficiently store excess renewable electricity? In other words, how can we store wind and solar energy when using hydrogen? Maybe you could briefly explain that to us again in more detail.
Yeah, sure. We are talking about the increased demand of the requirement of having more hydrogen available for the end use, for the different applications, but we also need to be careful on looking at how the green energy is there available. Is there enough green energy for producing hydrogen at the point of time that is required? And that was very well said by you, Michael, how to make this electricity be able to be stored in a format that it's easier. And then we are all talking about transforming the green electrons into molecules and be able to store them.
Is there any process today that is already particularly efficient? Or is it associated with high friction, meaning we actually lose a lot of electricity in the process? Or is it already the case that the transfer from green electricity, like solar and wind, into, for example, hydrogen, is very efficient?
Of course, one current technology that exists as not only as a energy storage or as energy carrier is the battery energy storage systems, which is quite good and it's quite efficient. But we believe also that it's not going to be only batteries or only hydrogen that will save the world or make the energy transition fully. It will be a mix between both, right? So then we will have maybe battery storage is a more complex system, and making this whole holistic a bit more efficient for the grid operators as well. So we have to look at both sides, one on the end use application, but as well on the grid operators, how the transmission system operators and the grid and the distribution system operators are able to make this power available to the applications.
Philipp, I think that's kind of your role. So maybe you can explain it a bit further. What challenges are the grid operators facing now? Hydrogen is a completely new topic for them, or maybe not entirely new, but it's certainly a new development that's currently happening in the industry. What challenges are they up against?
Of course, we don't have a constant situation. In general, the amount of green energy in the grid fluctuates significantly depending on the weather, whether we currently have a lot of wind or a lot of sunlight at any given time. On the other hand, we have a facility that can be ramped up and down, but not arbitrarily. Ramping the facility up and down naturally puts stress on the respective components. And in this context, as we already mentioned in previous episodes with the Hydrogen Performance Suite, we are, of course, trying to bring together different types of information. And this is precisely where the strength of this holistic, unified Siemens approach lies, that the various aspects must be taken into account in order to make the best overall decision on how to operate the facility. That is exactly what we want to create here. In practice, this is precisely what we want to offer our users.
A question for both of you. Mariana, can you answer? Are there any factors that affect the economic viability of hydrogen as an energy storage medium? So what do we need to pay attention to when doing something like this? Which factors affect hydrogen's economic viability as an energy storage medium?
First of all, it's the technology per se, so the electrolysis technology, which has been existing for more than 100 years. However, it is still not playing economics of scale, so it's not so cheap. If you're buying an electrolyzer, definitely it's not a cheap technology to go with. And the second is the balance of the plant, right? So the surroundings that you would need. So you need to put some some investment money also around that. So I would say two main things: maturity of technology, economics of scale of the electrolyzer, and the second thing for the rest of the balance of plant. So all the compressors, the water system, how to make sure that also the connection to the grid, so the power supply, the availability of the power supply from the grid connection, and so on.
Let me try to put it very simply, Philipp. If I simply have a solar farm next to my hydrogen plant and a wind farm next to my hydrogen plant, then it should actually be easy to say, I ramp up my hydrogen plant when the wind is blowing, and I ramp it up when the sun is shining. And when neither is available, I just ramp the hydrogen plant back down. But I don't think it's that easy, is it, Philipp?
Yes, so in the end, it comes down to, once again, what business model we have or what the goal of this plant is. We already talked about the fact that there are different approaches. There's basically the one who essentially comes from the renewable side, as you just kind of framed it, and who says, I have a wind farm, I have a solar farm. Basically, that means I'm essentially trying to use the excess electricity I produce myself for, depending on the current feed-in tariffs, and convert it into hydrogen. We have several companies that are pursuing such a business model, but there are also others who are positioned more at a point where, for example, a green steel plant is located behind them or something similar, where we actually have a continuous off-taker structure. That means these are facilities where the output of the plant essentially dominates. And of course, it's about possibly purchasing additional electricity from the grid that I can't produce myself. And now we come back to what was already mentioned earlier. It's an overall decision where I naturally also have to take into account the framework conditions of the plant. Mariana referred to it as the balance of plant, which of course must also be considered in the overall decision. When you look at the so-called LCOHs, the levelized cost of hydrogen, which consider both the capex of such a plant and the opex, that is, both the investment costs and the operating costs of the plant, the dominant cost factor over the life cycle of a hydrogen plant is, of course, the energy costs. That's why it's just as important to talk about what we're discussing today, namely the how. How does the energy actually get into the system? How can that be managed in the best possible way? And also how we can ensure things like grid stability and similar aspects.
It sounds extremely complex when I imagine it as a large ecosystem. You just mentioned the green steel plant. Now, let's assume it is a green steel plant. Then, of course, I also have to make sure that only green electricity is used in that steel production. Mariana, we just talked about wind power from our own park, solar energy from our own park. Maybe I'll even purchase additional sources. Now I also have my own hydrogen production process. You've internalized it. It's all in your head. Maybe you can show me again how such a hydrogen or green steel plant can truly operate in a green way. What the processes are, where the electricity comes from, where it goes, and how do you ensure that it really stays green?
The easiest way will be if the system is completely isolated from the grid. Let's start from there, because that will be the simplest case to say, yes, my hydrogen is really green because I have my own renewables connected directly, as you named before, right, Michael? You're saying, what if I have a wind park connected directly to the hydrogen, to the electrolyzer? That will be the easiest way to make sure that your hydrogen is really green, and you are doing that. The system starts to get complex because you connect it to the grid, and you wanted to also make sure that the power that you're taking from the grid is renewables. Some countries like Germany, you can buy renewable power 24/7, but some other countries you cannot, because it's not a completely green matrix in the energy system looking at the country. So then you have different hydrogens. It's all the same in the end of the day. The molecule is the same. It's not any change, but it could be a change on the levelized cost of hydrogen that Philipp is talking. So you could charge differently because the green is more premium. You don't have renewable available at the whole time, right? And how to make sure that these operations is running well, completely isolated from the rest from the grid. If you're completely isolated, you also need to have sort of orchestrator to make sure, okay, what to do in case of fluctuations. We know that the wind power is does not have wind all the time. It also goes up and down in the circles, in the cycles, and therefore you need some sort of orchestrator that is making sure that so an automation system like a power control that it's making sure what to do with the power source, with the power generation. And that also plays a role when you are connected. It makes a bit more complex, but you still even more need to take care about grid code compliance and regulations, because that are all the set of rules that the distribute system operator or the transmission system operators take care to make sure that the quality of energy that you are taking or feeding back to the grid is in the right level.
Now, it's not like there's a person sitting there all day pressing buttons and making all these if this, then that decisions. There has to be a high degree of automation and standardization involved. Can both of you give me a bit of insight into what already exists today? What is technically state-of-the-art when, for example, a hydrogen power plant is being built for a green steel plant? What already comes more or less ready-made from you that I, as the operator or owner of such a facility, can implement? Mariana, are there already any blueprints? Is there anything I can use in a standardized way?
Yeah, definitely. We did create two main blueprints. One is on what I was saying, the orchestrator, like a power control automation system that is making sure that from where the power is coming from at what point of time, executing this instead of pressing the buttons, as you said. Nobody wants to be sitting in front of a screen and doing this job. It's a bit complex and so on. And also to make sure that, as I said, the grid code compliance that is being fulfilled at the point of time that you need to fulfill, because of course the distribute system operator or the transmission system operators, they can shut your plant down if you're not fulfilling the grid codes. This is very important. And the second blueprint is on the electrical power distribution. I mean, we created already, for example, different, we call it e-houses. So it's like a containerized approach with the medium voltage power supply that you need and the low voltage switchboards that you would require. Of course, there are adjustments because it depends on the topology, which country, how big is your electrolyzer and so on. But we already create from the paper some blueprints on the project, pre-engineered so that you don't need to start from scratch. So we are already thinking how to have like a copy and paste as much as possible with small adjustments only or small customizations in these two topics, on the automation part, on the power automation, and on the other one, on the equipment itself, on the hardware as an electrical house, as an e-house.
Now, both of you just said, well, Michael, it depends on what the plant looks like. Is it independent with its own power supply? Is it a steel mill? You told me something recently, Philipp, about possibly even large shopping centers or commercial areas that can supply themselves with electricity in a self-sufficient way like that. So, different business models are emerging. Very small plants, very large plants, a plant that's used at only one location, and many plants that are very similar. How easily can such a blueprint or such standardization be adapted to different processes, to different requirements, or also be scaled when I realize this works well, it was successful, and now I need the whole thing 12 times over? Both of you can answer. Philipp, you start.
That's what's interesting about the topic of green hydrogen. We have the situation where the plants themselves are very, very similar in their components. Green hydrogen plants are always the same. You have the power supply, then you have the electrolysis, you have some kind of purification systems, you have intermediate pressure storage. You have water treatment. That means in terms of components, the plants are very, very similar. And that, of course, allows for the standardization of many things. Nevertheless, it's absolutely important. And I think we've heard this in all the podcasts and saw it again today in a very impressive conversation with Mariana, that there's still a significant part where we have to say it depends. Because in the details of how the plant is actually supposed to operate and what purpose it is meant to fulfill, whether it's to decarbonize a certain process or to store green energy temporarily, those specifics really matter. These are entirely different purposes and different business models that the investors are pursuing, and there are already very different things involved. And that's where we can help these clients, for example, by saying you standardize on a certain type of plant, or maybe you even create two standards. We also have clients with whom we discuss two standards. One of them is more closely aligned with renewables. This is a small plant that needs to be very flexible. And on the other hand, they have a large one that is more optimized for cost efficiency and high output. And for both, we adapt our holistic blueprints in such a way that they fit individually. That's why we standardize based on our Siemens standard. This standard is then further customized to the customer's own standards. And of course, you also take another look at the specific plant that is being built. Because we rarely speak with a customer who simply intends to build a hydrogen plant, a green hydrogen plant, but rather it's usually about building a first one that they want to replicate afterward. And that's exactly where they find the right conversation partners with us, because when these customers come to us, there's a very good chance they'll meet both of us, Mariana and me, together in one meeting. So you don't first talk to Mariana, then to Philipp, and then have to go somewhere else. We handle it together. Anyone who is now at the point of having to make these comprehensive decisions, these strategic decisions for their system, will meet all of us together. We all sit in one room and look at it together. And even in the first meeting, even at an early stage, we quickly move towards creating an initial rough concept together, putting it down on a sheet of paper or a digital document.
I'm really glad that you invited me to see it in your showrooms, so I could get a better understanding of what the word blueprint actually means. Because we're not talking about a PowerPoint template or a PDF document here. When you talk about a blueprint, you're referring to engineering templates, almost fully developed software plugins that can be loaded into your process automation or planning software for such a system in order to gain an advantage already during the planning phase, and possibly even be able to immediately ask you the most important questions. When we talk about these most important questions, Mariana, let's say I'm an investor, a potential customer. Maybe I'm planning 1, 2, or even 12 of these plants, and I'm feeling a bit lost right now, more or less overwhelmed by the sheer number of options and parameters I can set. Mariana, what are the most important questions we could go through together?
I think I would start off, which country are you thinking about it? Because the country will define also the rules that we need to fulfill, and also the grid availability. Okay, are you thinking about a connection to the grid directly? Is the grid the amount of power that you will need for your hydrogen plant enough, stable enough, or not? And another question that would come to my mind would be regarding, a lot of people are talking all the time about off-taker, right? So you have a fluctuating, a flexible off-taking, or you have a fixed one. So because this also will influence on how much, maybe if you're thinking about connecting, not only having a connection to the grid, but as well as having your own assets, this will affect how big the assets will be. How big should be your photovoltaic plant, how big should be your wind turbines, how big should be the battery for making the system stable when there is no hydrogen, right? When you are not able to produce hydrogen and so on. Because we know that electrolyzers are not so fast, right? You need time for them to ramp up and down, as we were discussing before. So that will be the starting point of my questions. I don't know, Philipp, do you have any others to that comes to your mind?
Exactly. For me, it will naturally be more about looking at, okay, what kind of impact does this have on the plant? How does the plant itself behave when you look at process engineering and automation in that context? And what kind of impact does that have? What does ramping the plant up and down look like? What impact does that have on maintenance, on the wear and tear of the plant? These are really the topics that need to be brought together into a comprehensive picture. But also, for example, very important, how does the customer actually envision the plant being controlled? Is it controlled on site? Is it controlled remotely? Does the customer operate it themselves, or would they prefer to outsource the control of the plant so that a service provider handles it for them? Then, of course, the question arises, does the service provider take on full responsibility, or are there certain indicators that they need to monitor regarding the wear and tear of the plant? We're always talking about degradation, for example, of the electrolyzers, but also, for instance, about maintenance. Who actually maintains this plant? We're going to see facilities where maintenance personnel aren't on site every week or on a daily basis. And these are things that need to be integrated into an overall concept. So we have a very long list of questions. We can't even go through them all here because I think there are something like 300 or 400 questions. They're, of course, cascade and worry. Anyone who comes to us doesn't have to answer all 300 questions. But we do have a long list of around 300 to 400 questions that we go through bit by bit over several sessions, or at least keep in mind. And that's already a benefit. I always say it's already a positive outcome for anyone who comes to us, just to be made aware of these important questions. And I always say these questions are already a treasure, because you only come up with them when you create a truly holistic picture. When someone like Siemens approaches this topic in such a comprehensive way and considers, what exactly do I need to clarify on the path I'm taking for my plant?
I can already tell. The vision of an energy transition is no longer just a vision, but something that can actually be implemented. You've already prepared the right questions, and you've also prepared the right answers to those questions. Now it's just a matter of, where does the energy come from? How is the energy properly converted? How is the energy properly stored? How do such automation processes take place? What standardized processes exist, and how can something like this be scaled? In which countries is something like this being implemented, and with what kind of infrastructure? What is the intended outcome? What is the customer aiming for in operating or introducing a hydrogen plant? I can tell. It makes a lot of sense to sit down with you further and continue the conversation. Gladly. And for listeners, these are the two best people you could talk to put the vision of the energy transition into practice, especially when it comes to hydrogen. Thank you both very much.
This podcast was done by humans but localized with the help of AI. Thanks for listening.